Hello everyone, welcome back. Have you ever wondered how your computer processes all the data you feed into it? It's like a bustling city with millions of operations happening at the same time. The sheer complexity can be mind-boggling. From the moment you hit a key to when a letter appears on your screen, there's a whirlwind of activity going on inside. This intricate dance of data is orchestrated by a crucial component of your computer. Today, we unravel the mystery of data processing in a computer. The heart of data processing in a computer is the Central Processing Unit, or CPU. Think of the CPU as the brain of the computer. Like our brain, the CPU is the command center where all major calculations and processing happen. It takes in instructions, processes them, and gives out results. The CPU is an intricate piece of technology consisting of millions or even billions of transistors. These transistors switch on and off at incredible speeds, allowing the CPU to perform calculations and execute instructions. The CPU's role is pivotal in a computer system. It's responsible for executing the operating system's instructions, controlling other hardware components, and processing data. The better the CPU, the faster and more efficient your computer is likely to be. Remember, every action you take on your computer, every keystroke, mouse click, or file you open, passes through the CPU. So, the CPU is the brain of the computer, responsible for processing data. But how does it do that? The first step in data processing is called fetch. Imagine the CPU as an efficient master chef in a bustling kitchen. The chef doesn't have all the ingredients on hand, so they must fetch what they need from the pantry, or in this case, the computer's memory. This is the essence of the fetch process. Here's how it works. The CPU utilizes something known as the program counter, or PC, which acts as a sort of guide. Think of it like a recipe book that the chef follows step by step. The PC points to the specific instruction that the CPU needs to fetch, just as a recipe would detail the exact ingredients required for a dish. The CPU then retrieves or fetches this instruction from the computer's memory. It's like the chef reaching into the pantry and pulling out the perfect spice or ingredient. It's important to note that this isn't a leisurely stroll through the aisles. The CPU operates at lightning speed, fetching instructions in the blink of an eye. Once the instruction is fetched, it's stored in a special place within the CPU known as the instruction register. It's akin to the chef placing the fetched ingredient on the kitchen counter, ready for the next step in the recipe. This process is repeated constantly as the CPU fetches instruction after instruction, always guided by the vigilant program counter. Once the CPU has fetched the instruction, it's time for the next step, decode. After fetch comes decode. This is the phase where the Central Processing Unit, or CPU, rolls up its proverbial sleeves and gets into the nitty-gritty of understanding the instructions it has fetched. You see, the CPU is essentially a multilingual master. It speaks the language of machine code, a series of ones and zeros, but it also understands the language of operations, the actual tasks it needs to perform. The decode phase is where these two languages meet. The CPU takes the fetched machine code and translates it into a set of operations that it can execute. This process is rather similar to how a translator works. Imagine you're given a letter written in a foreign language. You may recognize the symbols and the general structure of the language, but unless you know what these symbols mean, the letter might as well be gibberish. So, you bring in a translator who takes the foreign script and breaks it down, symbol by symbol, into a language you understand. That's essentially what the CPU does during the decode phase. But remember, this isn't a leisurely translation job. The CPU performs this decoding at lightning speed, translating billions of instructions every second. And it doesn't stop there. Once the instruction is decoded, the CPU moves on to the execute phase. It's a high-speed, high-stakes process, and the CPU doesn't miss a beat. It's always ready for the next challenge. Once the instruction is decoded, the CPU moves on to the execute phase. The final step in data processing is execute. This is where the magic happens, where the Central Processing Unit, or CPU, springs into action to carry out the instruction it has just decoded. Picture a master chef who has just read and understood a complex recipe, now getting to work in the kitchen. The execute phase is the equivalent of that chef chopping, stirring, and grilling to create a gastronomic masterpiece. In the digital realm, the CPU could be asked to perform a variety of tasks during the execute phase. This could range from simple mathematics, such as addition or subtraction, to more complex operations like multiplication or division. The CPU could also be instructed to move data from one memory location to another, much like a chess player moving pieces strategically across the board. However, the CPU's tasks aren't limited to just these operations. The beauty of this technological marvel lies in its versatility. It could be asked to perform logical operations, compare values, or control the flow of data within the system. It's like a maestro conducting an orchestra, ensuring each instrument plays its part at the right time. But remember, the CPU doesn't rest on its laurels after executing an instruction. No, it's not in its nature to pause. Instead, it immediately moves on to the next instruction, ready to fetch, decode, and execute once again. After the instruction is executed, the CPU repeats the cycle with the next instruction. So, that's a simplified view of how your computer's CPU processes data. We've taken a journey deep into the heart of your computer, to the Central Processing Unit, or CPU, the command center where all the magic happens. It's there where a three-step dance takes place countless times per second: fetch, decode, and execute. Remember the fetch step? It's where the CPU grabs the data it needs from memory. Then comes decode, where the CPU interprets what the data is saying, reading its instructions like a secret code. And finally, the execute step, where the CPU acts on those instructions, carrying out the tasks that keep your computer running smoothly. All of this happens in the blink of an eye, hidden beneath the surface of your everyday computer use. It's a symphony of calculation and processing that's easy to overlook, but essential to understand. Next time you use your computer, remember the complex processes happening behind the scenes. Thanks for watching.